Good evening, welcome back to Step 1, 1994. Here is question 3 from the paper, which asks us to consider the coefficient of x to the n in that identity 1 minus x to the n times 1 plus x to the n, which is obviously also equal to 1 minus x squared to the n. So we have to consider that coefficient and then simplify that big expression in those two cases. So if n is even or if n is odd, we need to be able to determine what that expression will be. So this looks very daunting because that expression doesn't seem very nice. You have a lot of choose stuff going on, and I know some stuff about choose, but I don't think I know enough just about choose to do this without any other external help. But the good news is they've given us some external help. So let's think about that. So we have 1 minus x. So on the left-hand side, we have 1 minus x to the power of n times 1 plus x to the power of n, right? So what's the coefficient of x to the n, right? That's what they've asked us to consider. So let's think about that. Coefficient of x to the n. Well, there are a few ways we get x to the n, right? So obviously I have 1 minus x times 1 minus x sort of n times, right? N times, but I also am multiplying that by 1 plus x n times, right? So if I want to get x to the n overall, I have to be kind of smart, right? Because if I get x to the n on this side, I have to get all ones on this side, right? But either way, I have to make a choice. At each bracket, I have to choose between either 1 or minus x, or on the right hand side, I have to choose between 1 and x. So if I were to use up all my x's over here, right, then I would already have x to the n, and I couldn't use any x's up over here. But there are other ways to do it as well, right? I could get x to the n in a few ways. So we're going to think about how many ways we could do that. Well, I think it's good to note that x to the n is equal to x to the k times x to the n minus k by indice laws, right? Because k plus n minus k is just n. So we're guaranteed to get x to the n if I choose x to the k, if I can get a coefficient of x to the k from the left-hand side, and then find the coefficient of x to the n minus k on the right-hand side, right? Well, the coefficient of x to the k on the left-hand side, what's that going to be? Well, if I think about this, I'm going to want n choose k multiplied by minus x to the power of k, right? To get me x to the k, right? That's really the only way I can get it with those sort of terms on the left-hand side. Because I need to get x to the k, and if I just multiply x by itself or minus x by itself, disregarding the sign in the front, the minus 1 or 1, because I can get minus times minus times minus. Disregarding that, I know that the only way I can get x to the k is by multiplying x by itself k times, because the 1 isn't going to do anything, it's just going to be multiplying by 1. So this is really the only way I can get x to the k from that left-hand side. So this is just exactly the same as n choose k multiplied by minus 1 to the k times x to the k, right? Because we can split apart minus x to the k like that. This is effectively the same thing we did in the beginning of the question with the 1 minus x to the n times 1 plus x to the n is equal to 1 minus x squared to the n. Because I know how I can combine stuff when they're raised to the same power. So I have that. But what about x to the n minus k on this sort of right-hand side here? What's that going to be? Well, it's going to be n choose, well, if I want to get x to the n minus k, I'm going to need sort of n minus k x's, right? So just going to be n choose n minus k multiplied by x to the n minus k. And this time there's no minus sign, so it's actually just going to be multiplied by x to the minus n minus k. And again, this is literally the only way that we can do it, right? I have to choose n minus k lots of x. If I'm only choosing from sort of the brackets on this side, I can only do it. I can only get x to the n minus k by choosing n minus k x's and multiplying them together, because the ones don't contribute anything. And then finding how many ways I can rearrange those is just n choose n minus k, right? So how many different choices I can make that will give me the same outcome, which is n choose n minus k. But I think we should think about n choose n minus k, right? So what do we know about n choose k compared to n choose n minus k? Well, actually, those two things are equal. And how do we know that? Well, by definition, n choose k is n factorial over k factorial times n minus k factorial, right? I'm also realizing this is going off page. Let me just try and, let me bring this back to sort of the center here. I think I'm sort of also veering off the side of the page a little bit. So let's just go back to where we were. So we have n choose k is actually equal to n choose n minus k. And the reason for that is because by considering the definition of n choose k, it's just n factorial over k factorial times n minus k factorial. What about n choose n minus k though, right? Well, that's going to be n factorial over n minus k factorial multiplied by n minus k, right? Which is just k factorial. So this k factorial is also the same thing as n minus k, right? All factorial. So that's why these two things are equal, right? Because if I just plug them into the, like, this is the definition of n choose k. But if I were to replace the k here with an n minus k, then I get n minus k factorial, n minus k factorial. So I just get the same thing, just flipped, right? So hopefully you guys can appreciate that those two things are the same. So yeah, so we have that n factorial over k factorial times n minus k factorial. It's just the same thing as n factorial over n minus k factorial times k factorial, right? Doesn't matter which order I multiply things, the denominator is the same. Okay, so those two things are equal, which means that obviously we're also multiplying these two terms, right, to get our x to the n term. So ultimately what I'm going to get is n choose k times minus 1 to the k times x to the k times, again, another n choose k, right, since n choose n minus k and n choose k are equal, x to the n minus k. So what does this end up giving me? Well, it ends up giving me n choose k squared multiplied by minus 1 to the k x to the n, right? But again, we're asked to consider the coefficient. In the initial question, it says consider the coefficient of x to the n. So we just disregard this x to the n, right? The variable doesn't matter. So the coefficient we care about, is n choose k all squared multiplied by minus 1 to the k. But there are multiple different k I could choose to get x to the n, right? I could choose, k equals 0. I could use k equals 1, all the way up to really k equals n. So there are n choices for my k. So if I sum over all those possible choices, right? So what I'm going to want to do is I'm going to want to add up all possibilities to get my complete coefficient of x to the n in that sort of multiplication of two brackets, right? Because I could get x to the n like this if I just choose a k, like if I choose k equals 2, this gives me one of my coefficients, but there's multiple different ways I could get x to the n, right? So I need to add up all the possibilities. Add up all possibilities to get x to the n. So namely, it's going to be a sum. So if you're unfamiliar with this notation, it just means I'm summing things from k equals 0 to n of n choose k squared multiplied by minus 1 to the k, right? And if you're unfamiliar with this notation, I can just write that out. That is just, so I start by plugging k equals 0 in. So n choose 0 squared multiplied by minus 1 to the 0, that's just 1, right? And then minus n choose 1 squared, right? Plus n choose 2 squared. And you can see that this is actually, this will keep going on until we get n choose n squared times minus 1 to the n. And so it turns out this is our overall coefficient of x to the n, right? So this is sort of the overall coefficient of x to the n. Overall coefficient of x to the n. But the overall coefficient of x to the n is just what we're asked to figure out, right? That is just that sum that they've given us at the beginning. So the question is actually equivalent to asking in the expansion. So if we go back up to the top, so the question is effectively asking us, so the question is effectively asking us what is the coefficient of x to the n in the sort of binomial expansion 1 minus x squared to the n. Right? That's basically the question, right? We don't even care about that sum anymore because we know that that sum is just equivalent to that coefficient. So that's sort of irrelevant now. Now all we need to do is look at this binomial expansion and say what's the coefficient of x to the n? Well, I guess in the first case where we have n is even, then there is one way to get x to the n, which is, so ultimately what we have is 1 minus x squared multiplied by 1 minus x squared n times, right? So we have that n times. And the one way to get x to the n is to have minus x squared to the power of n minus 2, and then multiplied by 1 to the power of n minus 2. But we're also going to have the number of ways we could arrange that. So it's going to be n choose n over 2. Sorry, did I say n minus 2? I meant n over 2. So it's going to be n choose n over 2 times minus x squared to the power of n over 2. Obviously also multiplied by 1 to the power of n over 2, but 1 to the power of n over 2 will be 1, right? And since n is even, n over 2 is going to be, it's going to be an integer. Namely, it's going to be a positive integer, right? And so that means that effectively what's going to happen here is I'm going to get this. I'm going to get n choose n over 2 multiplied by minus 1 to the n over 2 and then x to the n, right? And that's perfectly fine. So the answer for sort of part I of the question is just the coefficient of that, which is this. So the answer to part I is n choose n over 2 multiplied by minus 1 to the n over 2. Right? What about to part II? Right? What happens when n is odd? Well, think about this. Can we even get x to the n if n is odd, right? Because remember, n is going to be an integer, right? To even be odd, really, there's not really like like when we say n is odd, we're always talking really about positive integers. So like 1, 3, 5, 7, 9. So we are dealing with positive integers here, which means that effectively this n is going to be a positive integer, and so I'm doing this multiplication n times. Now, obviously, you might think that it might be the same answer, right? N choose n over 2 times minus x squared to the n over 2. But the problem is this isn't quite right. If n is odd, then it doesn't have a factor of 2. So n over 2 isn't even an integer. So this wouldn't even be possible, right? Because think about it. I'm making a choice of minus x squared at each bracket. So I'm choosing whether I want to multiply by 1 or minus x squared at each point, at each bracket. So I'd have to make n over 2 choices to get minus x squared to the n over 2 of minus x squared, and n over 2 choices of 1s, and then rearrange those, n choose n over 2, sort of there's n choose n over 2 different ways of doing that, of me making that sort of choice from each bracket. But n over 2 here is not even a whole number, which is a problem, because that would indicate I'd have to make sort of half a choice, which doesn't make any sense. So if you think about it, right, just multiplying these minus x squareds is always going to give me an even power of x, right? Obviously the 1s aren't going to do anything, right? So no matter how many 1s I add in, they're not going to do anything. But multiplying these minus x squareds gives me x to the power of an even number. So if n is odd, then the coefficient of x to the n is clearly 0. right? So that isn't quite right. It's not the same as before. Actually, the answer is 0. The answer is simply 0, right? So everything just cancels out, since if n is odd, the coefficient of x to the n is 0 in the expansion 1 minus x squared to the n. In other words, if I multiply minus x squared by itself multiple different times, I can never get an odd power of x. Simple as that. So the answer is 0. Okay. Nice question. Difficult, but nice. All right. Thank you guys for watching.